So this video is all about multiplying fractions and mixed numbers. And so what we'll do is we'll go through a few examples using some familiar fraction scenarios. In this case, in particular, we're going to talk about pizza and slices of pizza as a way of creating a very physical representation of multiplying fractions. Then we'll expand it a little bit into what it actually means to multiply fractions, the process for multiplying fractions, the processes for multiplying mixed numbers and fractions or mixed numbers together, go through a few example problems, and of course have some problems for you to do on your own at the end of the video. And a lot of what we're going to talk about in terms of understanding how fraction multiplication works and why it works the way it does is based on the things that we have seen in class for the last few days, particularly the way that we break down a fraction like 7/12 into what the 7 and the 12 both mean and different ways of looking at it. So first, before we do this, we're going to talk about, as I said, a scenario, in particular pizza. And in this case, the pizza that we're looking at has 12 slices. And so I'm going to give you a few seconds of quiet airspace here so you can think about the idea of if one pizza has 12 slices, what fraction of the pizza does one slice represent? And of course, if our pizza is split into 12 total pieces, that's going to be our denominator from the physical form of a fraction. And then we have one slice, so we are going to call that 1 out of 12. And so when we have physical things like that, like one slice out of 12 for a pizza, one slice represents 1/12. This number also represents the value of 1 divided by 12, or 1/12, one equal part of the total value of 1. This is a repeating decimal, and we'll get to some repeating decimals later, but that's the meaning here for 1/12. Now, if we had 3 slices of pizza, I'll give you a few seconds of open air space here too, so you can think about it. If one pizza has 12 slices, what does 3 slices represent, or what do 3 slices represent as a fraction? And so if one slice is 1/12, then 3 slices is 3/12, 3 out of the 12 possible pieces of the pizza. This also gets at something that we were talking about before, where we talked about how 3/12 is actually also can be thought of as 3 copies of 1/12. And when we're talking about pizza, it's really easy to see that 3 slices is 3 copies of one equal slice, where each slice represents 1/12 of the pizza. And so now we're going to start moving into some ideas around fraction multiplication based on slices of pizza, so we can see some patterns start to develop here. And so let's say 3 people each had 3 slices of pizza. Now there are a number of ways that we could talk about this. So first, I'm going to give you some open air space. So you can just think about, you don't have to write down, how many slices of pizza would we have in total? And one way you could do it, of course, is to count at the bottom. If 3 people each had 3 slices, 3 times 3 is 9. The other way we could look at it is that we know that each person has 3/12 of a slice of pizza, and there are 3 people who have that. So that is 3 times 3/12. And so if we multiply 3 people times the fraction of pizza that each of them have, we should get the total fraction of pizza. Again, each pizza still has 12 slices. The total fraction of pizza that we want in terms of having 3 people have 3 slices. And so what our answer should be, because we know that there are 9 slices total, is 9/12. And we can see in this case that 3 times 3 is equal to 9. So if 3 people each have 3 slices of pizza, we've already talked about 9/12, or 9 out of the 12 slices of the pizza. Notice, because we're just creating copies of something and we're not changing the number of slices, or we're not changing the thing that we're referencing to, the 12 stays where it is. So we can think about it as 3 times 3 equals 9. And since 3 is 3 over 1, 1 times 12 is equal to 12. Let's look at another example. If one pizza has 12 slices and we want to take 1/6 of the pizza, we want to take 1/6 of these 12 slices. And 1/6 of 12 can be thought of as the same as 1/6 times 12. Now we could split 12 slices into 6 equal pieces, and we could do that by saying 12 divided by 6 is equal to 2. And 2 slices of pizza is 1/6 of the pizza. But if we're looking at this in terms of fraction multiplication and what we did before, we know that 12 is the same as 12 over 1. And so if we take the strategy that we had before, where we had the numerators 3 times 3 being multiplied together and 1 times 12 being multiplied together, we can do the same thing in this case and have 1 times 12 equals 12 and 6 times 1 equals 6. And then 12 divided by 6 rather really is 2 slices of pizza. Now, what if we had a slightly more complicated fraction, like 5/6 of the pizza? Well, the same idea still works. We want to take 5/6 times 12. And essentially what we want to do is we want to divide 12 into those 6 pieces and then create a group of 5. So we're going to divide it into those 6 pieces. For example, 1/6 is 2, and then we multiply it by 5 to get 10. When we're looking at fraction multiplication, if we continue with that strategy we saw before, 5 times 12 is equal to 60. 6 times 1 is equal to 6. And 60 divided by 6 is, in fact, 10. Because remember, the fraction bar means division. And in this case, we can simplify down to a whole number value for pizzas. And so the way that we would actually go through and solve a problem in terms of finding the unit fraction, we call it, the 1/6, and then multiplying it by 5, because after all, 5/6 is the same as 5 groups of 1/6, informs how we do fraction multiplication, with the numerators being multiplied together and the denominators being multiplied together. One last example before we get to the specific concept. Let's say we have 9 slices out of the 12-slice pizza left, and we want to take 2/3 of that. So now we have 2/3 that we're multiplying, but now we're looking at 9 out of 12, or just 9 slices. Let's find the fraction of the pizza that we're looking at. We could take 2/3 times 9, and 2/3 of 9 is 6. But we're looking at the fraction of the original pizza. So 9/12 is what we started with. 2/3 of that is what we want to take. So again, we want to divide this by 3, which means each of our denominators, because we're splitting it into thirds, we're creating more pieces because 9/12 is not a whole number. So 3 times 12 is 36. We can split each of those 12ths into 3s, and then we get 36. And then 2 times 9, because those are our numerators, are 18 over 36, which gives us 1/2 of the pizza remaining. And if you took 2/3 of 9, you would find out there are 6 slices of the original 12. And so each of those problems presents a slightly different way to think about how, when we're multiplying fractions by fractions or multiplying fractions by whole numbers, what we're doing is we're multiplying the numerators together and then dividing by the denominators. But the denominators, if we have 2 denominators like we do here, as opposed to just one denominator, or where a denominator is 1, we have to multiply those denominators together too. And in fact, that's how we multiply fractions. We multiply fractions by multiplying the numerators and setting that over the multiplied denominators. So the new numerator is the product of the original ones. The new denominator is the product of the original ones. We simplify that, we multiply through, and very important, anytime we do that, mixed numbers need to be converted to improper fractions, and we'll see why in class tomorrow. So go ahead, pause the video, write everything here down, including the algebra, and we will come back to it in just a minute. So now let's take some practice with multiplying fractions, doing what we've done before. So 4 times 3 is equal to 12. That was our process. Multiply the numerators, multiply the denominators. 5 times 8 is equal to 40. We can simplify that down by dividing by 4, rather, to get 3/10. So 4/5 times 3/8 is, in fact, 3/10. Now, for the example on the right, we need to convert these to improper fractions. And 1 2/3 is the same as 5/3. 2 1/2 is the same as 5/2, and 5/3 times 5/2, 5 times 5 is 25, 3 times 2 is 6, our answer is 25/6. Now if you prefer to convert that back into a mixed number, that is 4 1/6 as an alternative there, but 25/6 is perfectly fine because it is in fact simplified. So now let's give you a chance to work on some practice problems on your own. Go ahead, pause the video, work these out. Remember to simplify. Remember the numerator of our product is just the product of the numerators, and the denominator of the product is the product of the denominators, and come back when you're ready to move on. So in 3/5 times 2/3, 2 times 3 is 6. 5 times 3 is 15. Divide those both by 3 to get 2/5. In 12/25 times 3/4, 12 times 3 is 36. 25 times 4 is 100. And if we divide by 4, we get 9/25, which is the product that we want. Now 3 1/5 down in the bottom left, we have to convert to a mixed number. So 3 times 5 is 15 plus 1 is 16/5 times 7/8. 7 times 16 is 112. 5 times 8 is 40. You can divide both of those by 8, it turns out, and you get 14/5. Or 2 4/5 if you prefer. And then for 22/7 times 3, we have to remember that 3 is the same as 3 over 1. So that ends up at 66/7 because 22 times 3 and 7 times 1. That is the same as 9 3/7 if you prefer to convert it back into a mixed number, although that is certainly not necessary. 66/7 is simple. So again, multiplying fractions. We multiply fractions to get the product. We multiply the numerators. We multiply the denominators. That becomes our new numerator and denominator, and then we simplify as we need to.